Hi. So we have more solder stuff to do. So I tried to do the desoldering of the chip this morning. I think I spent over an hour on it. It still did not come off. So it's... oh yeah, hold on. One moment. Yeah, my computer didn't boot for the stream for some reason. And then I realized, I wonder if the kernel updated and it broke something. Lo and behold, yep, went back to an older kernel. Worked just fine. It must be some driver for my weird streaming hardware video capture nonsense. Casey Opspus? Wow, that was an interesting way to phrase that. But Case of Space, thank you for the tier 1 sub and for 28 months. I appreciate that. All right, so let's go over what the actual problem is here for those of you who may not have been here yesterday. So we have fairly well diagnosed the issue. Whoops. Hold on. One moment. Why does this keep unplugging? One moment. Okay, we have fairly well diagnosed the issue with the microNOVA to being a chip on the CPU card, and I need to replace it. And I probably can by using one from... Man, I got so much closer on the other one, and I need to reflow it a little more. I need to replace the chip with that one from that spare RAM card that I killed. Well, not that I killed it, died. And then I fixed it so it would work now, but we're still going to harvest parts from it. So, yeah, sub messages have never shown in chat. Anyway, they show up below chat, like down there somewhere. Anyway, so we need to desolder a part from the board to remove it because it's bad. Here's the problem. This is the chip in question. Now, this is something I recorded earlier today. I'm gonna let it play to get to a slightly more stable frame here. There are no annular rings on the top side of the pads for this thing at all. And that makes it extremely difficult to heat the solder evenly. So you'll see that there's little bright spots of solder where the legs are touching just the via ring. And that solder I cannot get out, no matter what. I don't know what I can do. It's so bad that this morning I did this. This is my hot air pencil mounted on a stand so that I can position it anywhere I want. And up here is an upside down vise with ESD foam in it that I can slide the PCB into and then clamp it in place. I put this back there, heated the chip up to 100°C on each side so that I could get some heat back there, and then tried to remove the solder from the back. It's just, I can't. The capillary action holding the solder in place is so strong that it just doesn't move, even if it's liquidy. I cannot get it out. Now, due to how fragile this chip would be if I tried to touch anything to the top, we can't do that. So solder wick, absolutely not. We're not going to get anything from the bottom because all the solder is on the top. And if you've never worked with a slightly damaged board that has the annular ring removed, you wouldn't know this, but the via cylinder wall is extremely fragile. So if I tried to get solder braid anywhere near that top side, it would just push the annular wall or the via wall away from the PCB, and it would just instantly destroy it. So we can't do anything up there with the soldering iron. Found I had to dump a lot of heat into the board, then tug the chip out, clean up the rings after paintwork. Yeah. Need giant iron tip, heats up all the pins at once. That exists for the Metcal. I've never bought one because they're like 80 bucks. I could probably get them for the tweezers as well. But again, that would probably be like 160 bucks because you need 2 of them, and then very, very unique. So yeah, but the hot tweezers I have are not acceptable because they're not gonna, I can't evenly heat the whole thing all at once. So hot tweezers are not going to be the answer here, unfortunately. Have I read your suggestions? Is it bad for sure? Maybe Dremel it off, remove the pins individually? Oh, no. I'm super not doing that. Matter of fact, if we actually get it off, we're going to test if it's bad. So I would like to do that. Because these are irreplaceable chips. I mean, I say that we can't get a drop-in replacement for this chip. I might take a stab at designing a replacement for this chip, but there are no replacements that we can get. So, but here's what we're gonna do. All right. So instead, I don't need suggestions right now because I have something we're gonna try. So here's what we're gonna do. I'm gonna flip this around in this setup. All right. So let me remove the board. I'm gonna flip this around. This is the chip we're removing. There's no solder mask on this side, so I'm not going to mark it because it will never come off, but it's that one. There we go. So it's this one. I'll clamp that better. We're going to use actually solder temp air out of the hot iron there. And then we're going to use the heat gun from the front to try to double side heat the chip. And then I'm just going to try and pluck it. Because I think nothing else is going to work. No direct source of heat applied to anything metal on there is going to do it. I think we're going to have to use global heat on the whole thing, but I want to be extremely careful about it. Now, I can dial in the temp on that thing, so that's why I'm leaving that one back there like that. This, I cannot dial in the temp. I can only get it closer or farther. That's as good as it gets. So we're going to use that on the back. I'm apparently going to have to mute my phone. One moment. I posted about this on Mastodon. It's apparently too interesting. Hope it will not kill the IC. Yeah, low melt solder. I don't have it. Doesn't matter because the problem is capillary action, not actually melting the solder. Low solder is not the answer. Or low temp solder. Remove hot air nozzles so the area gets heated is bigger. Yeah, I might do that. I'm also, though... Well, yeah, we probably want to evenly heat the board, let it radiate out. Because the other thing I was thinking is I really don't want to, like, loosen any other parts. Because it would suck to, like, have the resistors and stuff just, like, fall out because their solder melted. Yeah. 1010, I tried to do that earlier as well. It didn't help. The problem is that every single leg is just slightly stuck. And slightly is a risk for the angular rings. I did damage one angular ring on the backside already today. So that's unfortunate. The trace must have been on the top side because it didn't actually go to anywhere on the bottom side, but still sucks. So yeah, I'm really not happy about this. This is very frustrating. So Kapton tape on the back to shield the parts we want to keep. Well, I can do you way better than that. I was already planning on doing this. So, or is it up here? That's the fresh stuff. It was the one I actually used. Oh, come on, I know it's in here. Or is it here? Where is it? Was I weird and put it in with the fresh stuff? I don't think I would have. No, that's... I got sealed. Oh, that's not what I thought it was. Oh. Where is it then? That's a metal sheet for trying to ground something larger. I didn't really end up liking that solution. Where did this go? I have a really good solution for this. I just don't know where it went now. Ugh. Cool. And now there's stuff stuck under this drawer. Awesome. Okay. A lot of stuff stuck under the drawer. Okay, one moment. I would really like to find this, so I am going to actually look for this for a second. Huh. Where'd it go? Well, I'll just say what it is, because I have had it on video before. Teflon sheets with a hole cut in the center of it. Because that will allow me to deflect all of the air away from the things that I don't want it to hit. I don't know where it went, though. I have one that's already cut, and I should have some unused sheets as well, but I don't know where they are. Thought I found them during the reorganizing, and I thought I put them in this drawer. But I might have been mistaking them for the grounding sheet. The foam won't melt. The heat's not going to be directly on it. And if it starts to do anything weird, I'll be able to see it. I don't have a better solution than that, so it's that or nothing. Yeah, I got no idea where those went. That's annoying. All right, you know what? We'll just have to go without that. All right. A resistor arrays in the board almost the same height as chip in a socket. I don't know. I am really nervous about chip in a socket not fitting. We're gonna do it, but I don't think it's gonna fit. All right, let me position this slightly better in here. So it needs to clamp on this side. A nice open spot in the middle. All right, relatively solid. The one we want to remove is that one. You know, I can pinch the foam up at least. Oh, yeah, Ben, we can test fit. I mean, the bigger concern right now is actually being able to remove the part without destroying the PCB. That's the bigger concern at the moment. Okay. Yeah, pretty much. It's not going great. I am not making a potentially poor choice here. There are no other options. It has to be hot air. Proper heat gun's a lot of watts. Yeah, that's why it's being plugged into the one outlet that I know goes to a different breaker. So that one is on its own breaker, and this one should be on its own breaker. Soldering iron is off. Plasma is off. So. I really wish I knew where that Teflon sheet went, though. That's going to bug me a lot. Because I know I found it while I was cleaning. I guarantee I did. And I thought I put it somewhere smart, you know. Giant heat gun to be temperature adjusted if you run it on the Variac. Yeah, but it draws more power than the Variac is meant to do. I'm not really thrilled about trying that. All right, let me pull the tip off of here. You know what? No, I want to leave that on. I want it more directed because I don't want to heat up the entire board. It's easier to see from the other side. Need a bigger Variac. Wait, you're not using an actual hot air station proper controls or something? No. So you may have missed this, Ben. I have the actual hot console mounted on a tripod or on a mic arm on the back. And I'm going to set this to like 220, maybe 250C to melt the solder. And it's going to be pointed directly at the back of the chip. But then I'm going to use my just straight up heat gun from the front to try and more evenly heat the chip. And then once it's warm, you know, I'm going to try and just pull it off. And we'll see how that goes. I can't apply any leverage to attempt to pull it off or it'll destroy the board. That's the concern. 350 and it was still a challenge? Well, yeah, maybe instead of 3. But that's the plan. Let me angle it from over here. Preheat your board? I mean, this is preheating. I don't know what you mean preheat. I'm not soldering to it. I'm just hot air only. Unless you mean slowly ramp up the temperature, which I can do that. All right. It's pointed basically as good as it's going to get. No, I don't want to remove the nozzle because I only want this part to be hot. I want to heat as little of the rest of the board as possible. Yeah, leaded solder should go hot at much lower temps. You guys are soldering with garbage RoHS, so that's why you're getting it, you know, got to be so high. So like melting temp on this, I guess it doesn't actually say, or that's on the part that broke off. But yeah, it should be like 220 at most. So I don't want to do this, but I can't think of any other possible solutions. It just has to be hot air. All right. Let me think about this. I need an out with the heat gun once it's hot. So let me plan for that here really quick. I don't have a metal tray. I do have metal racks, though, somewhere. Where did I put those? Although the metal racks just kind of end up letting it slide. Okay, hold on. So I move that. Have this here. That'll work. Okay. Point it directly at the bottle of alcohol, yeah. Are we trying not to destroy the component? More importantly, we're trying not to destroy the motherboard. Well, motherboard, the PCB, because the PCB is extremely fragile. All right. I'm kind of done explaining it. We're going to go now. All right. I'm going to let it start at 100. Let it heat soak at that temp for a bit. And I'm going to start recording here. Cut legs. No, because I want to test the part after. This is a irreplaceable component. So if it's not bad after external testing or something, I don't want it to be destroyed. So Mighty Halo, apparently Data General used the worst possible PCB vendor on the planet. If I tried to do a giant solder blob across this, all of the traces would just rip up with it. And I would have to rebuild the traces from scratch. It's not shorted. That's not the problem. It doesn't close or something like that. Sorry to hear that. Yeah, that's the problem. All right. That's probably, yep, that's warm. Bump it up to 150. I will go to 250. Our camera see board is warm. I think the board is warm. Pretty sure it's warm. I'm not setting that up right now. I need to order another USB-C extension cable and like 4 more of the garbage mic arms. Then I can just have that set up all the time. All right, let's get into the can't touch it point, going up to 200. You can see the ultrasonic cleaner right there. I don't know what you're talking about. Ultrasonic cleaner just sucks to use. It doesn't make sense on streams. And then a lot of times it doesn't make sense because the things aren't that dirty. I do wish I could have this slightly angled out. It's not a camera trick. It is angled in towards the bench, although the camera is probably slightly angled wrong, but whatever. It is just like that. All right, going up to 250. All right. That was concerning, but the power strip is off. All right, that does work. I'm going to bump this up to 3. Max airflow? No, the difference is somehow 500 Fahrenheit or 1000 Fahrenheit on this, so I would rather not have the insane high temp. The legs can't melt solder. I'm mildly concerned about heat soaking it for this long. We're gonna get a little more aggressive. Oh my gosh, let go! Seriously, why? Maybe I need more solder on it. No, it should be slightly farther away than arm's length because you want to be away from the fire when you go and get it. What do you mean no tech talk today? That's right. Okay, hold on. Okay, now Deck Talk is back. Thank you for the 100 bits, Chloe. All right, I'm applying more solder to the back of the chip. I think I'm going to have to. I think there isn't anything for it to heat. It's warm.
NEODRAGON 90 subbed as tier 1 and says was going to wait until concentration was as needed, but someone started a hype train exclamation point. End of line.
Hold on here. Apparently the
tier 1 and says and we kill Hipachum. End of line.
Things are not updating as they should be. Ben, thank you for the 100 bits. Dr. Stoffel, thank you for the 100 bits. Neo Dragon, thank you for the 34 months. My hands are full of hot things. Hiram, thank you for the tier 1 sub. And for 36 months, my hands are still full of hot things. All right. We're putting a lot of solder on this. I have a feeling every single person who's recommending low temp solder, no offense, is also used to working with Rojas, not lead. Okay. All right. Back to high temp on the back. I am still leaving the nozzle on. The way that the heat will be dispersing will be fine. I'm going to go 350.
Dr. Stoffel gave a tier 1 gift sub to 5 viewers. End of line.
Dr. Stoffel, thank you for the 5 gifted subs. I really appreciate that. trying to watch for the solder to melt on the back, so I'm constantly poking it to feel. Because if it doesn't melt on the back, then it's definitely not melting on the front. Oh my gosh, more airflow? Why is it not melting? Oh my gosh, just to stop it. There you go. No nozzle. none of the solder pads were melting. So it wasn't a matter of concentration. If none of them are melting, then that means that the whole thing's not getting hot enough. Not melting. Is 450 really the max? No, it's not. But I'll do 450 because at this point, I don't even know. One of them is melted. Oh, I'm super scared for the PCB. Three, 4, 5, 6, 7, 8. Come on! Ah! Oh. Jeez. That was awful. Run this down to cool. Oh, man. You applaud my patience. I really Really did not want to damage it. Really, really didn't want to. Not sure I didn't. Can't tell what's flux and what is not, but yeah, one more to go. That's the problem. We have to repeat this on this thing. This has angular rings on the top, though. Who would have guessed? That's crazy. So it should be much, much easier. Oh my gosh. All right. Yep, that's still nice and toasty. Do not like having got that warm, but it's not like I had any other choice. I don't think I should rapidly cool it either. I think I should just let it air cool. Test remove chip first. Yes, I do actually plan on doing that. That was something I said I wanted to do because I want to validate that it is actually bad. You know what? We can just let that cool as we set up to do that. Oh my gosh. The same pinch just on my Tempest board, burned several sections of it. Did eventually get it working though. Ooh, that's unfortunate. Ever soldered BGA chips? No, that's not realistically hand solderable. Sure, some people will tell you they've done it before. It's not realistic. Oh my gosh. So, if I had found this earlier, that's a Teflon sheet that would allow me to deflect all of the heat from the places I didn't want it to be. Cool. Probably would have made it go away faster as well, because it wouldn't have been soaking as much heat into parts of the board that don't need it. All right, I think I got a breadboard in the other room. I'll be right back. Yep, there's a breadboard. It's got an ESP32 on it. We don't need that. That's for dumb stuff. Boo, ESP32, boo. Okay, well, there's some good boards on there. I'm going to leave those. Okay. I'm going to do some lead forming on this real quick. ESP32 is more powerful than the entire DG. Shh, don't tell it that. It'll feel sad. The Stay High or Silent Searchlight, I put that into the same category as having the person who literally worked at Disneyland to do like design of visual effects stuff, repair 8-bit guys Apple II. It's not something that's practical for everyone to do. Or I think it was Retro Recipes, or was it Parafractic? I think he renamed his channel. Rebuilt the Atari 1200 using like modeling clay or something. And again, not practical. BGA soldering is not practical. Okay. We need to review some data sheets. Yay, data sheets. Woo! I'm just bringing up. Actually, they should be on the computer. I don't need to bring them up. I mean, yes, sure, they're impressive, but whenever I see something like that, I have the reaction I'm having now where I know that I'm going to get comments about it saying you should do this because other person did it, and it's not practical. Just like it's not practical for other people to, you know, have their entire HP electronics test bench like this for being able to work on stuff. You know, different people have different skill sets, different equipments. It's not everything is practical for everyone. All right, so what I'm doing is I'm bringing up the data sheet for the 634 here. So we can, did I just somehow zoom the UI? I swear it just got bigger, didn't it? Not this. Like I think this I managed to zoom or something. I don't even know how. All right, where's the 634? Oh, that thing is touchable. Okay. Here we go. 634. Come on. Package. Here we go. Oh, maybe I just wiggled it like that. Okay, VCC and ground. Okay. They're in the expected places. Ground. And let's go all over here. VCC. Okay. What are ground in VCC? VCC is 5 volts. That's easy enough. So I am going to grab power supply output. It's a shame I can't just, or can I? Wait a minute here. So on the data sheet, ground is ground, GND. VCC. You might be thinking of VSS. That one is ground. Was this cross-threaded or something? There we go. All right. Just gonna grab a small LED. punch the hot iron thing. Ouch. 200 ohm resistor. Pull the resistor bin forward so it doesn't fall over the back and make me very, 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 very sad. Power to here. Put this way farther down. Power to there. Ground to there. Okay. Disconnect both of these. Okay. Power supply. We're using the 50 volt. That's the 33. VSET 5, enter. ISET 0.1, enter. Why? Those not actually touching. Multimeter time. Is that LED blown out? Or am I dumb and have the polarity backwards? Oh, or no, this isn't one of those weird. Okay, hold on. Volts. That is the wrong power output. That will do it. All right. And of course, this one's flipped. Why? How did I mess that up? Okay. Now do I have this backwards? Oh my gosh. Okay, 5 volts. There we go. Jeez, that was stupid. All right, we're just gonna have to use jumpers. Okay, output off. Ground. Ground. That's not a jumper. That is power. Power. Okay. On. Power indicated. Okay. There we go. I'm going to bring this down. Turn this off, maybe? Nah, let's leave that on. I'm going to behind the PCB works, though. Okay. LED's like USB right the third time? Yeah. I think I had it right the whole time as far as everything there. It was just all that nonsense. Okay. So we need... Oh, they're bidirectional. That's weird. Huh. Okay, when A is asserted low, enables A as inputs. Okay, so we need a pull down. What value is this that I pulled out of here? Probably 1K. 100K. That's a lot. I'm just gonna grab a 1K for a pull down. Okay, so we need to pull down, what is it, A in, which is pin 1? What? Yeah, pin 1. Okay. Let's turn the output off. All right, I'm also gonna do this. Is this the RAM board, the blue tantalum? The one that I pulled the part off is the CPU. Okay. Now we get fancy. I want this, and I want some stuff here, and we get to use the jumper legs that I pull off for stuff for one of my favorite use cases here. The needle pliers go. There they are. It's not jumpering across the breadboard. You'll see. That's just a convenient place to put them. Just make these farther apart. Okay. Output is off. I should be able to connect this now. That's backwards. Just had a thing in my hand. Where did I put it? Did it fall on the ground? Am I? Yeah, I'm not bad. Okay. Sure. This is going to take a little bit to set up here. Give me a moment. Oh, actually, I can use that. That will be super nice. Okay. Well, in that case, this just got a whole lot easier. I want another jumper. I don't have one. Let's make one. I'm going to grab a super thick leg from a resistor or something. I'm going to put it in the pliers, and I'm going to just bend them over. Now I have this. I'm just going to stick this on the ground side. There we go. Now I'm going to clip this ground onto that. This ground, or power signal thing, onto that. I'm going to go to this. I'm going to grab some probes. I'm going to take the yellow one, and I'm going to put it on heat. Yep, nope, that was not that strong of a jumper link. Let me make a better one. Oh, that one looks pretty good. There we go. Okay. Oh man, are the colors wrong? That's super annoying. Oh, I know what the problem is. Amplitude 1 volt. Okay, all right. So now we do a thing over here. One moment. They don't make longer scope leads, at least not ones that don't cost $70 each. It's also not the problem. And here we go. Okay, so I am using the signal generator over here. I'm going to set the frequency. It's at 1,000 hertz here. We can see it down there. If I... Is there an off option? Doesn't seem like it. Well, here, that's supposed to be a sine wave. For some reason, it's not really looking that great here. I'm just going to delete all, continue, and then end these one at a time just to make sure it's not showing up here. Unless that's it on yellow, which is where it should be. Why is it being so weird? There we go. Okay. So, offset. Yeah, let's just bring this up. There we go. So there's our input. Okay. So we're going to feed this into this chip. This chip may only work with square waves, so we might have to use this, which is fine. What do you mean, what, Ben? We're doing signaling. So just to make sure I have both set up correctly, here is green. Good. Well, that's kind of good. Why is the... Hold on, C2. There we go. You realize you use square wave in time, it's okay? Yeah. Okay. Chip's not like input, does not like its input going below 0. Okay. Then we can do something here. So voltage peak to peak is 5? That doesn't make sense. Shouldn't be that high. amplitude 0.5 volt. Let's try that. Okay, 1.25. All right. So that's straight volt. DC offset 0.5 volt. So that should do it. There we go. All right, you want 5 volt with a 2.5 offset. Yeah, I know. I was just trying to make sure I had it right. So 5, no, that's DC offset. Hold on. Okay. DC offset, 2 point, that's completely wrong. DC offset, volt. What do you mean error? Because it's probably higher than the whole thing. Amplitude, 5 volt. DC offset, 2.5 volt. Okay, so that is weird looking. But now it's 13 volt peak to peak. What? Amplitude. I'll set it to 2.5 volt because I think it's dumb. DC offset, 1.25 volt. This is the 16500Z, yes. Probe is set to 10x. And it is set to 10x there. Like I misaligned the in size the controls are. That's like someone put it together. Point click GUI designer. Expecting to drive into a 50 ohm load, be putting out twice voltage. Oh yeah, we could terminate it. That'd probably be one of them smart things. Don't terminate, just set the generator to expect a high Z load. I don't think I can do that. I don't know of a way of doing that on the 3325B. There is no button like that. Unless it's that. That change anything? Doesn't look like it. Then you do the math yourself. Well, that's what I just did, and now it's 6.25. The probes are not adjusted to it. Counts the overshoots. Okay. Wish I could see a minimum voltage on this thing, but yeah. I'll see a high Z option in the manual. Yeah. The probe compensation is set correctly. It's set to 10x right here. I mean, I don't know about, I don't think we want to change the impedance. But yeah, probes are already 10x. What, do you want the probe set to 1x? Turn the little hole in the end of the probe to make the square flat. What? See probes you guys got. These are just garbage from Amazon. What are you talking about? No trim pot. There ain't nothing like that on here. Well, if it's on the plug side, then it may as well not exist, because we're not getting to the back of the HP16500C. Ain't happening. Guarantee you that. Trying to find where I put the Tektronix 320. I'm not going to use it for this, but I want to look at the probes on it. Because they are, oh, right here. Similar, if not the exact same, generic garbage probes. Oh, I was smart and took them off. Thanks, me. They just right here? Yeah, okay. So, yeah, these look basically the same. Oh, yep, there it is. It's on the plug. Well, that ain't happening. Properly adjust the probe so it doesn't get bad readings? Don't think so. All right, well, that's close enough then. All right, well, we're at the point I wanted to be, so I'm fine with this. All right. Oh, you know what I think I can do here? I think I can do, not that. There you go. Now you can have the scope while we're doing other stuff. The problem with fancy probes is that they be long fancy probes, and they basically just don't exist. That's the problem. The thing about the 16500C here, all right, you see, you can't see anything. It's about this long, and the probes plug into the back. So you waste about 24 inches of cable length just to get back to the front of the unit. Then it's whatever you have after that. So it is extremely difficult to get appropriate length probes for this thing. All right. Oh, there's the thing I was looking for. Of course. All right, so these are open collector, which I believe means we need to tie them high or low. So test circuit number 1. They're using a 140 ohm and a cap. Load capacitors include jig. Straight capacitor, yeah, okay, that's whatever. Okay, so we're gonna just put a 1K to tie the inputs and outputs, maybe? Well, it's got to be only the output. From output under test, yeah. So we'll do, it's pin 3. 1, 2, 3. Tie that. Need this to move. Tie that high. And we can take a jumper here, not pull that out, connect that to the output, which will be high, should be. Well, the output's off. Okay, although actually I want to do a different thing first. I'll do this. So 6, 2, 3, 5. Oh, that's what? Okay, we need pin 5. 1, 2, 3, 4, 5. Input. That is output. No, we need this. There, and then this will go here. Okay. Whew. Yeah, that's both sides are inputs and outputs. Yeah, I was just looking for the correct A-B ordering. Yeah, I know that extension cables are a bad idea on the scope. That's why I've never even attempted it. Okay, so now we can turn power on. It got pulled low. Why? Oh, maybe the chip. How much power does this draw? .2 watts. So that's an amount. I said 0.2. Enter. I think it wants more power. I said 0.5. Why would it be pulling that much? That's average power dissipation. And it's having the chip connected, puts it into output protect mode, VCC. Really hope I didn't kill it by desoldering it. I think I made an error. That was maybe my fault. Hopefully now I didn't kill it. Why? Okay, no inputs or outputs, just power. And it goes into overvolt. Chip wasn't that dead. Yeah, everything is removed now, except for power. Need pull-ups on all signal lines. Oh, that's gonna suck. All inputs or all outputs? Say both, you want to be 100% soft percent. All right. We're going from 1K to 2.2K because I don't have enough 1Ks for this. And this one's a 100K. Get that back. All right, let the fun begin. Getting the probes out of here. They should all be tied high. Just this is where the open collectoriness I am not sure about. I'm guessing. So tie everything high. Well, all right. Let's have fun. Except for A in, that one gets tied low. When inserted low enables A inputs is that, and that's pin 1. So that one goes low. Yeah, I have to have the pull up. Yep. This is going to be a challenge.
Laumo says CHEER 100 : The chip will go. End of line.
Laumo, thank you for the 100 bits. BN is 19 when inserted. High enables. Okay, so that one should go low as well. Thanks, air compressor, but I'm good. You can stop. I don't need it. Thank you, though. I do want my coffee, though. Every video that has the air compressor featured in it, I always get someone commenting about water being in the tank. Every time. Doesn't matter. Every single time. This is the life of publishing a bunch of your work on the internet. I'm going to go through all this and it's still just going to go into overvolt. I know it. They've never had water come out when I've drained them. Yeah, exactly. Oh, there's definitely tons of glue all over. I don't care. There's no way it's not going to be, because I'm not dipping each one of these in isopropanol or something.
David Phantom says water in an air tank. You mean someone thinks the incompressible liquid is in the compressible medium storage facility CHEER 100. End of line.
It's more they think water vapor that gets drawn in with the air will be condensed in there, and then it will settle in the bottom, and then it will rust the tank, and then the tank will explode. That's their real concern. There'd have to be water vapor in the air for that to happen. Inside a building with an air conditioner running in Arizona. Ain't gonna happen. Okay. All kinds of resistored up now. All right. Output off, reset on, and it immediately errors. Why? This is what it's doing. Output off, reset, okay, on, and that's what it does. V set is 5 volts, I set 0.5. Now, isn't OV over voltage? I don't exactly remember. You know what?
90 SIZHEER 100 resistance is futile. End of line.
Let's just consult the book words. All right, book words, what do you got? Error bit code 67 through 610. Okay, 6, 7. OV. Okay, OV. Over voltage protection tripped. How is it overvolting? It's set to its own voltage. Not picture books, yeah. Is the input signal still active? No, all of it's disconnected. If I disconnect ground and power from the chip and then turn on power, hold on, I said whatever, just enter, whatever. Out on, boom, LED. It registers as drawing 14 milliamps. That's all perfect. So it's the right power supply, it's the right output voltage. Like VSET 3, boom, LED goes dimmer. I mean, it's working correctly. VSET 5, that's all correct. Is it seeing a dead short? That's a good question. Out. Did I barbecue the chip to death? Doesn't seem like it. So that reads 0.3 ground to VCC 34K. Diode test mode. I don't know, 1 volt drop. So I'm not sure what you were saying, Helencroft. Connect the ground of the chip with the PCB with the power supply on. So you just want ground connected? Out, on. We're good there. Yeah, I connected all the breadboard stuff at the bottom. So that's with just ground connected to the chip. Now, hot plug power. Love it. Instantly overvolt. Then it killed power. What chip is it? Excuse me. Well, are we back? Back? Okay. I mean, I'm guessing the chip legs are making power. Missing point connection. So top of chip leg, good. Top of chip leg, good. Top of chip leg, good. Yeah, the power pins are all making contact. Yep. Here's power all the way back to that. Ground all the way back to that. All good. Just as I try to answer the question, Data General MN634. There you go. The noise compression is not on. There is no noise compression. Or noise cancellation. Dude, I got no idea. Here's what I'm going to do. I'm going to swap to the other power supply just because I'm bored of this one. See if it acts less stupid. Okay, disconnecting. Main IC, VSET 5, enter, ISET 0.2, enter. Okay, power, boom, out, off. Ground to ground, power to power, out, on. It worked. Dude, what's wrong with the other power supply? Wait a minute. Could that block thing be loose again that they're all connected through? Oh, you jerk. I bet it's that or something like that. Okay, never mind. We're going to roll with this. Okay, I think we got it. Stupid power supplies. Okay. Now let me reset up the test. So Pin 1, 2, 3, 4, 5. Okay. I'm going to assume I don't want an input that I'm actually using tied high, because then I won't be able to read anything from it. Or read anything into it. Send it a signal. I'm going to disconnect that. Okay. Yellow trace is input signal. Once I reconnect it, green trace will be output from the chip. So there's input. Everything pulled high, your signal should be able to override it. You think the signal generator is going to pull current? If it pulled high through the resistor? What do you, just give me words. Just give me words. Just tell me. You know what? Pass. I'm just hitting the button. Boom. Okay, so it didn't work. Output off. If you have resistor to 5, it's fine. You can drive it low with the SIGGEN. If you have it shorted to 5 with a wire, no. Okay. So you're saying put a resistor. It's a 2.2K resistor. It's now connected to the SIGGEN. RIP SIGGEN. Didn't work. It's not outputting anything. That's weird. Okay. Has push-pull currents. He has to pull down an up resistor. Okay. Huh. All right. What's the deal? Okay, 2.2K across the output of the SIGGEN. It would help if I knew how to count. Wait, no, I want 5, not 4. A1, A2, yeah, that's it. B0, A0. Oh, or my... No, I want 4, 5. 4, 5. I misunderstood how the chip worked. Okay. Out. There we go. Okay. That's actually the chip driving it, okay? That's working right there. Working. Okay. All right, now I can record. Jeez. All right, here we go. All right, so I have removed the chip from the board, and what I have done here is set up a breadboard test circuit with the chip, and I'm actually feeding it a signal from my HP3325B signal generator here. It's going into the second set of input and output buffers, and we can see on my HP16500C, which has an oscilloscope card, that we are getting a signal going through it. If I stop the output on the signal generator, which I'm just going to do by unplugging it, we'll see we get no input and output, and there we go. So the yellow trace is the input going into the chip. The green trace is the output. Now, what I'm going to do is I'm going to move the input and output to the lines that the chip select for the RAM on the CPU board uses. So here we go. that optocoupler in it, no, that buffer is dead. There we go. The chip is confirmed to be bad. It has a bad buffer driver. So that one gate right there is the problem that was most likely keeping the Data General microNOVA from being able to access the RAM. That one gate. Because again, the chip itself is working. If I move this back to the other buffer, we get signal through. Not sure you can say that. What do you mean? It was chip select. It couldn't select any RAM. That's why DRAM on the CPU board isn't refreshing. I mean, I don't know, we'll see. Oh my gosh. But I can't use RAM on the other memory boards, right, either, and that's completely independent of this chip. Yes, which is super confusing, and I don't know why that's true. So, yeah, you are correct. I was wondering that exact same thing. I don't have an answer. I'm going to take some pictures to send to Usagi, because he's been absolutely fantastic about helping me. He'll appreciate this. You have thoughts. Yeah, you want me to probe the backplane, I know. You gotta admit, though, we found an actual fault. I've never explained them before. Oh, you have explained them before. I'm just inept. I think the address decode in the async card is screwy. Ah, so... I haven't given you all of the information, Ben, but yeah, fair. Definitely an actual fault, and it's good progress. Just don't think we're home and dry yet. Yeah, me. I don't know 7,400 chips offhand, so I have no idea. All right. That was a good find there, finally. Jeez. Dude, what's wrong with the other power supply, though? I would really like to know that at some point. So this is a fun thing here. Mini tangent, all right? So, I have been procuring all of the documentation for every single piece of test equipment that I have over there. Because I want to be able to just reach up and go, here's the manual, I got it. So here's the manual for the Spectrum Analyzer. It's a binder. It's really cool. And I did read through like half of this thing in the PDF, and the PDF scan is not amazing. This is for my single output power supplies. It covers both of them because they're basically the same. They just have different power ranges. This is the quad output power supply, so I'm really happy to have that. This one is absolutely fantastic. So this goes to the 3478A multimeter. It may as well be a, here's how you program this with an HP85 manual, though, because it spends most of its time talking about that. Also, oh yeah, gorgeous, fold out. Come on, you don't get that in a PDF. So, yeah, this thing, that manual rocks. And then, yeah, I have some other stuff. So, I have been really loving this. Yes, all the manuals were scanned by other people years and years, like a decade ago. Maybe actually even all scanned by HP. So, yeah, I'm super happy with these. Actually, this can't go in there. I don't think it will fit. There we go. I might get a second one of these, because then I could put this. Wait. Oh, that's deeper than that thing. But I have another thing that I've been working on you guys might find interesting. These are all very common pieces of technology. Maybe not the spectrum analyzer, but yeah. So here's something I've been working on. I showed you guys this the other day. So this is a laminated sheet with the photos from the microNOVA CPU. This is to let me write markings on here. So I measured voltages and stuff on this, and I wrote it all down. I traced out where some stuff was going, and because it's dry erase, when I'm done, I can just wipe this off and then set it aside in case we have to do something else with it. So I did get like a really nice laminator. I mean, I've been working on some stuff, and one of the things I have been wanting are easy reference sheets for different things. So this is a pinout for VGA, some common modes with the number of pixels per line and the number of lines, a breakdown of the timing diagram for like how the VGA signals work, and some notes about all of that. Then down here, we have D-sub serial. We have a 9-pin port there and the 25-pin port there. Black pins, by the way, are ground, so you can easily see where those are if you want to probe something. Information on how to set up, like baud rate, parity, and all that kind of fun stuff. Here's a description of how a serial packet is designed. On the back, we have the pinouts for the 2 motherboard COM port header kinds, as well as descriptions of what cables they use, whether it's the interleaved one or the split one. Information about DTE versus DCE, just to make Ben sad, and then kind of a warning about UARTs and TTLs and how you can't put that kind of stuff in there. So yeah, I'm making some of these for myself because I'm putting these in my little thing here, and boop, and then next time I'm working on a VGA thing, it's like, I need to know what VGA pins are. Boom, right there. Yeah, I may sell these. That's a very strong possibility because they're kind of handy, and I think it could be a thing. But I am waiting until I have at least 5 of these done. I'm going to sell them as a bundle, because selling them independently would be kind of stupid.
Says, I appreciate your continued devotion to making me sad about RS-232. CHEER 100. End of line.
You're welcome, Ben, and thank you for the 100 bits. They are hand laminated. I managed to find myself a, I'm going to call it industrial grade hand laminator, and it's excellent. It's a personal touch that keeps me coming back. Can you even buy a laminator anymore? I bought an old one. That's awesome. Dude, it's so good. It's real good. What's wrong with DTE versus DCE? Nothing, except that they're dumb. Well, one of them's dumb, and I now know that the dumb one is DCE. Hold on, I want my tablet thing here to send those photos to Soggy if I can. So you bought a $20 one for Liddy for laminating some signage. Yeah, so my goal here is to laminate and make pages for like a bunch of stuff. Not an industrial laminator collector. No, I don't think I'm going to go for many more of them. That's not a goal. I just know he'll get a kick out of like directly knowing that the chip is
Network 17
out.
As Prime and says evening all. End of line.
You know, one moment here. Let me hide that, not that, this, because we're done with that, and that will let me go back over to here, and I'll have an easier time seeing chat and other things. There we go. So I use the workstation computer over there to show chat and like rewards and stuff, and then if I video capture something else, it makes it difficult. So. Resistor films to make PCBs. That's interesting. Double checked, you can replace bad chip with sub-4 if you bend up one pin and connect it to pin 20. Really intriguing. I'm going to guess that's one of the enable pins. Well, that's super good to know. That would be information I would appreciate being in Discord so that I can look into it later, because I am planning on trying to lay out with a SMD version of a semi-compatible chip and then route all of the changes onto there. The direction pin that's not used. So yeah, I want to be able to get that RAM board back, because here's the thing. So the RAM chips on this are 606 RAM chips, which are the 4K RAM chips. I think the 607s might be the 2Ks, and because one of my RAM boards is 2K, it means that I have 30K of RAM, not 32K of RAM, I think.
Tier 1 and says end of line.
One moment, and it would be cool if I could get all the RAM, you know, like all of it. That would be cool. Why is this not updating? There we go. Okay. So from a moment ago, Network 17, thank you for the Prime sub and for 18 months there. And Baloo, thank you for the Tier 1 sub and for 3 months. Okay, did this just finish uploading? Probably didn't finish scanning. Yeah. Completely different pinout. I will have to look at it. I guess I can turn off that chip. Is it warm? Well, that chip is actually noticeably warm, yeah. Oh, man. I'm enjoying this break where I'm not trying to do something really difficult over there and standing and you'll humor me for a moment. I am appreciating this. Why have all of the images not been uploaded? Oh, stupid Google. Or is it stupid phone? I don't even know. So, it's been doing this thing recently where I will take like multiple pictures at once with the phone to like make sure, you know, like that one was a little blurry because I felt like I was wiggling, retake it or something like that. And it started grouping the photos together. And I think the way that Nextcloud works, it can't access like all of them. And I think it just merged several of the photos. Oh well, I'll do it all from my phone. I hate typing on my phone. All right, so you need an interposer board to shuffle the pins around wherever you do. Yes, that's what I want to make that PCB. You'd have mod PCB in between for pinout only. Yeah, that's what I want to do. Why is it so hard to extract the chip? Because there were no angular rings on the top side, so it was almost impossible to get the solder to melt at the top. So it's really difficult to get all of the solder to melt evenly through. So it's, yeah, that was the problem. For two sides coming out in a matter of hours. Ooh, sweet. That'll be cool, Digital Ice Age. All right. Okay, one moment here. Hold on, me and touchscreens don't get along. There we go. Okay. You can't simultaneously say Nextcloud is the worst and that there isn't a better option. So it's both the worst and the best. You gotta mixed messaging there. Is Nextcloud perfect? No. Do I still really like what it allows me to do, all with self-hosting? Yes. Okay. There we go. So, now we repeat the fun by desoldering the other board. Yay! I guess I can turn off SIGGEN. It's just up there spinning its wheels. Turn off all of it, actually. Okay. All right. Second worst windowing system in existence with everything else tied for first. I'm really glad that that chip, worked partially, because that meant that I didn't kill the board or anything on the board probably. So that's really nice. Now we have to remove the other one, which again, I don't think is going to be as difficult. There are topside annular rings on this one, I think. Maybe, hopefully. Please let there be. There's also solder mask on the whole thing, so they'll be slightly stronger. All right. Oh, I'm so excited that part's off. I guess I can turn off the 16500C as well. Boom. All right. All right, moving along. This chip might as well just stay on here because it's not getting used for anything else, at least for now. Fun fact, there's someone who's selling a bunch of Data General chips on eBay. They don't have that one. It feels so wrong to have done that to the PCB. We should spend a little bit of time cleaning this up first, actually. So let's do that. That's new. There a... No, that's all flat. Where did that come from? Okay, it might have tried to melt. Okay. Bad foam. Oh, man. I'm happy right now. Okay, now let's make me sad and rip off some pads by accident. Okay. Hey, it didn't melt and stick to the board. That's what I was concerned about. If it just got a little hole in it, who cares? I wouldn't be surprised if... Yeah, I really don't know how that happened, actually. That's weird. I wonder if I bumped it with the tip or something. Anyway, I'm warming up the desoldering iron so that we can finish up the board. Plus, we're going to use it for the other PCB, too. Okay, where's coffee? Coffee's over there. Bet you can't guess which chip I removed. Maybe I should scrub that first. One of these days I'm going to have to put more isopropanol in here. That day is not today. That's crusty. Maybe I should have cleaned off the flux first after I added more solder, so it didn't get baked on. Oops. You saw nothing. It's really not cleaning up well at all. Use some piranha solution to solve the carbon deposits. Yeah. Yeah, it might be discoloration, but I really think it's burnt flux. Like, there's definitely goo. If I had acetone right now, I would actually try it, but I don't. Normally, I'm not a fan of acetone because it's a little too strong, but this probably needs it. Well, that's probably going to be as good as it gets. All right, let's clean up the vias. Let's turn on the correct iron and then wait. I think it's more that it is super crispified Robo Twilight, not that it's that there's a lot. I think that it is actually hard, and it would take something more aggressive to break it down. Did you find your fun isopropyl by Amazon? If I remember correctly, go to the My Tools video that I did. I think I found it again and relinked it there. How's the Data General project going? We found a dead part. Like an actually dead part. I think this was actually a brand new toothbrush. All right, now we can start pulling solder out. What? There we go. U3 is the same chip as U20, which is the one I just pulled. But any viable 7400 series replacement chip is going to be infinitely easier to get the Data General part. Lost an angular ring. That was a weird sound. Dude, those are brutal. Sage, were you here for my streams where I tried to do AV1? It's not trivial. Stupid camera ball head. Okay. All right, H.265. I think that worked, but it just made more sense to use an NVIDIA card for that. There we go. All right, well, after confirming that the chip was indeed bad, I cleaned up the spot here, so it's ready to receive a new chip here. Really curious to see what that gets us. It's a little torched from the repair process, but it all looks fine. I lost 2 pads in total, but they were ones that aren't used on this side, so it doesn't matter, although, yeah, there they are, right there and right there. So that will be fine. But yeah, it's just so annoying how small the pads are on top. It's made this nearly impossible. But now we need to remove the part from the other board. Can't overheat those trays, they'll come right off. Yeah, definitely. One. Yeah, we don't actually know if the bidirectionality matters. Okay, set this one aside and bring out the donor. You can tell from the schematics, several of them are being used unidirectionally, like U20. Okay. We're going to do a socket. Yes, we could install that right now, but we're not going to yet. Let me check something really quick. Okay. I'm not thinking that far ahead right now, Vorpal Sword. I just need it to work. Only U3 and U4. U20, use bidirectionally, okay. All right, so this is a spare Data General memory board that I bought on eBay a while ago. Tried to put it in the computer and it smoked, and I found out that this cap down here was bad. I replaced it with this. I haven't tested it since. It probably works now, but it doesn't really matter because I don't need it. Oh, I just noticed this is 607 chips. Okay, I'm now even less concerned about replacing this because it, wow. Dude. What is wrong with Data General, man? I lost my train of thought here, because the markings on the chips are just going any way they felt like. What? They're alternating every single other chip here. That's insane. Dude, you really have to be on your A game when you're populating this thing if they're doing that. That's ridiculous. Anyway, I'm not sure if this is a 2K or a 4K board, but it doesn't matter because my system did not have this board in it initially, so I don't need it. So even if it works now after replacing that, it's not required. So we have 2 of the microNOVA 634 chips right here. We're going to go ahead and remove one of them, and I'm just going to arbitrarily pick this one on the bottom side right now as our donor part here. So we're going to pull this chip, and then that will go in the CPU board so that we can find out if it will work with a functional, maybe one of these. We don't know if that works, but we can drop this into the breadboard that we just made to test it. So we'll be able to find out before we put it in the CPU card if it works or not. Now though, time for me to figure out how I'm going to remove that. I'm going to not film this in 4K. You're getting stream VOD because I'm not wasting all that footage space on just this again. Pin 1 markings are consistent at least? Yeah, but again, you got to be really paying attention here. Does that mean they were hand stamped by a person? Jeez. Donor sound much less cruel than sacrifice. All right. We're going to go straight into desoldering and hope for the best. Maybe this one won't be so stupid. And on the bright side, if I mix them up and pull off the wrong one, as long as it's still the right part, it doesn't really matter. Modern dips, you can't read the markings anyway. They could afford pick a place in 77, but not laser etching for their ACs. Some of them are really hard to read, too. It's very annoying. We're going to use the iron first. Where's a good perforator? That's the weird one. I want the good one. Actually, I think tweezers end up being better for this. Let me try that. I'm going to try and bend up the legs without using the desoldering iron because, you know, it's probably like a smart thing to do. Too. Yeah, that one would have been impossible with the desoldering. Wow. Figure out the problem with the chip? Yes. Just clip that. There's a dead output. I would like to point out as well that the signal generator just, like, it was the right tool for the job there to test that chip. Mic died. Test. Looks like it's good. Missed the signal generator. That's weird. I don't know what would have happened there. What I was saying is the signal generator was actually useful for a real project, not just messing around with something. So it was a worthwhile purchase. Because I didn't have anything else that could have done that. I mean, unless I used like the test point on a scope or something. That would have been stupid. Or rigged up a microcontroller, which, I mean, possible, but kind of lame. I'm going to clean this again. Just to be sure, because it's kind of gotten a lot of action. Ah, great. I think it might need it. Jeez. Ugh. I don't know what's going on. I'm going to cut this in case the tip of this is too marred up now. More coffee, more faster. We can test that theory. I think it might be jammed up. Great. I'm getting it to push through now. Not that time. So I have a solid core copper wire that I push down the channel to try and clean anything out. Oh, that's not that's not ideal. For a number of reasons. Ruh-roh. My gosh, how bad is this? Came with a cleaning wire. Your Metcal didn't. My Metcal was used. I didn't buy it new. Probably cost like $3,000 new. So I don't feel bad about that. There's something not right going on. Well, just going to continue and hope for the best. I don't see anything super problematic. All right, continuing. It's that one. All right, now we just need to figure out which ones are stuck, work on loosening those, and also find the pokerator, because I am super duper good at losing it. Fine, we'll use Pokerator Junior. Not loose. Not loose. Not loose. Not loose. Not loose. Okay, this is gonna suck. This one's like bent. I'm going to try something a little different this time. I'm going to flood this with flux.
STEELFLIGHT 82 subbed as tier 1 and says end of line.
One moment. And now I'm going to resolder that all. SteelFlight82, thank you for the tier 1 sub and for 20 months there. I appreciate that. So I'm going to try and flood the whole thing with my better solder that is more likely to flow. And I will pull it all back out. Why did you get a Metcal over any soldering station? I mean, it is a soldering station, but Metcal is just the best. Metcal is at the point where you're really not going to find something better. You're going to find something different, but you're not going to find something better. That people's opinions are going to be the larger influence on the things that they recommend. Almost had a job at Metcal. Dude, I would be super happy. That would be awesome. Need to let that warm up a little more. Just take a second while it does that. All right, let's see. Weird arrangement of pins. Oh, yeah. All right, this proof should be warmed up now. I did not think we would spend like 5 hours on soldering this weekend to work on 2 parts. Gosh. I couldn't imagine doing this with the solder sucker. Even the good Soldapult one, this would have been a nightmare. Okay. Gonna play. Nope. Okay. Now we get to the point where we start trying to wiggle individual pins. Did I finish job by now? Use proper solder wick. Oh yeah, sure. Okay. You're right. I would have removed all of the pads and thrown away the data generals by now. I think these are still sticking on the top. Gosh, this is rough. Try and detach them from the side walls. Now, I'm very familiar with the process of how to do this. It's just performing it without destroying the pads. Because I press down to heat up the pad, then I lift slightly so that I don't drag the tip on the pad and only bend and wiggle the leg itself. It's this delicate balance with a heavy, hot item. that, and you have to assume the data generals bent the legs in some kind of sensible way. What I think has happened is they didn't really bend the legs that much when they put the chips in. So the chip legs normally bend out like that. What I think they did is they put in one side, then kind of pressed the other side just enough to get it in, and then it sprung out. They bent the tips over and then soldered it in place. So between the walls, the leg actually bends away, out, and then down and over. So it is making contact on both sides at once. So I'm having the same problem as before. I am not getting these to move in a way that makes sense. I'm contemplating a more drastic solution using solder braid, but not in the correct way. Thinking about making a solder bus that can heat up all of the legs at once and then just try and push it out on one side. I think I'm going to try it. Oh, come on. Stop moving out. All right, I'm going to change tips. I want the gruntier one for this. All right. They had 2. Oh, I do have 2. You know, actually, if I put 2 bars like this on there, I might just be able to use the tweezers. Hold on. Wait a minute. An idea is forming. I do have 2 stations. I keep one at home so I can do soldering at home. But here, I could possibly... Nope, it won't fit. Stupid giant tweezers. Okay, there's no reason to do 2. Well, I might still have to lift, but we'll find out. Kind of hoping I get this going and then I can just desolder from underneath and it works a lot smoother. Okay, I got that side slightly raised. That just removes. Okay. Stay in place, stupid metal bar. So that's a lot of hissing coming from the solder, geez. Come on, lift. Some very farty solder down there. I think I need to continue to apply pressure. Is this high enough up? I could actually do it without touching the PCB. I don't think I'm carrying enough thermal mass. Well, maybe. Oh yeah, it moved some. Okay, I'm gonna hold. Nope. Hold. Cool down already. I'm gonna do the same to the other side, and then I'm gonna remove the solder braid and then desolder, and I think it'll work. It looks discolored because there's flux on it, that's all. I would rate this method as mildly dangerous to the PCB because you can't lift pads like this. Not my favorite thing to do by far. Okay, I'm going to stop there, let it cool, and then desolder. No, the desoldering station is working. It's just this is a nightmare. These chips are put in a really weird way. Do I have hot air? Yeah. So I took out the last one, but it kind of torched the board, and I'm trying to avoid that. I have solder tweezers. Tips for them are like $100. Additionally, you don't just want the longest ones possible, because if I did that, it would hit these and those, and then it wouldn't work. So you have to get them in like a bunch of different sizes, and then now you're looking at like $1,000 for a bunch of different chips. I don't do this that often, so it's not worth investing in that. Most of the time, I'm using this thing for just removing capacitors. What time is it? Oh my gosh, it's already 1. Jeez. Come on. I really didn't want to spend 5 hours on this. Screw it. Going all in on the chip wiggle. No, but Ben, one of these days I'm gonna actually have to finish the project of the original service sheets. I need to recreate them because I have some blanks. I just need to get them scanned, and then I want to like vectorize them and reprint them, and then I'm gonna start my own service logs. Just haven't had the time. I'm too busy doing other stuff with them. Ah, finally. Blah. I don't think I damaged the board either. Whew. Okay. I'm going to clean this up. That's warm. This must be some really nasty flux. Ah, bad. Oh, that side actually cleaned up. Okay, cool. All right. Better than the other board at least? Yeah, that's what I was aiming for. All right, so there it is, the dememoried or de-transceivered memory board. All right, let's clean up this chip. Hold on, let me actually start recording. All right, I just finished extracting this chip from the other board, and I had to use methods I didn't really like, but I didn't like the methods that I used last time either. So I'm going to clean this up now so that we can put it in a socket, and I do have to attach the socket to the other board still, but... Oh, let go. But yeah, so let me spend some time on this. How can I hold this? I got a stupid solution. Perfect. I don't think it's helping as much as I thought it would. I'm going to try pointlessly to clean this yet again. Gosh, it's so bad. I don't know. I'm going to stop before I break the wire off in it. It's not even pretending to pull. Nope, completely blocked. Fun. Not sure how I'm going to fix that. I know I'm seeing everyone say solder wick. Right now my concern is why this is not working. Well, that's a problem. A completely different tip. I want to see how this one works out. So not discolored. I wonder if I've ever even put power to this one. They take forever to heat up, though. Okay, it's starting to smoke. Yep, that's perfect. So the other tip's clogged somehow. Cool. I don't think I have ever used this one. It's making all kinds of weird smells.
JJDB 210 subbed as tier 1 and says, end of line.
JJ, thank you for the tier 1 sub and for 37 months. My hands are a little preoccupied here. I appreciate that. There we go. No solder braid because you guys wanted it too much. All right. Okay, what gives? This flux must just be super gooey or something, and this isopropanol is not getting it dissolved. I'm actually remembering a legitimate reason why I don't like solder braid. It leaves behind tons of little copper strands. Okay. Think we're good with this chip. Now, just to get my socket size here, I'm going to put this in here. Just 2? I only need 2 off of this? Ugh. All right. That's going to be annoying. Oh, wow. These don't pull out like I thought they would. Okay. That's going to be interesting. Now, to socket this part, I need only 2 more positions out of this one, so I need to cut this to be smaller, which is going to be fun to deal with. Okay. Now I need to probably sand that flat a lot. All right. That'll work. Surprise, we still have to test the chip to make sure that it's good. What do you mean, beep? It's fine, whatever. Who cares about that? No, wait, it is that. I'm just on the wrong thing. One moment. There we go. Figured you were going to skip this step. All right, and square wave. Oh, that's real ringy. Cool. Why? Sure. Why not? This is whatever. Okay. All right, there we go. So that is found a better replacement chips in live channel. Perfect, thank you. Doesn't need a little piece of me to move the pins around the right place. That's beautiful. I'm fine with that. Okay. So, this is the old chip. All right, actually, let me do some recording here. Okay, so again, this is the old chip. If we look at the scope diagram, this is the output 1, not output 0. Output 0 is the bad one on this chip. So if we move the input here over to that one and the output there, let it follow, we'll see the green trace does not show up this time. That's because that output is bad. So let me disable power to this. We'll leave the signal going because it doesn't matter. But now we're going to put in the chip we just recovered from the donor board. We'll see what that looks like. All right, so this is our new 634 here. Turn on power, and why are we not getting output? Okay, that's correct. And then that is correct. Okay, so those are both good. I want to try something really quick. Okay, nothing. That's as it should be. And then what? Well, I'm going to replace one of these jumper wires. I don't trust it. Phew. Phew. So here's the thing. This is behaving strangely. That shouldn't be working right now. So we are currently connected to pin 4. Can the highlighter not just like draw? Highlighter. No, I can't just arbitrarily draw it. That lame. Okay, fine, whatever. We're currently connected to pins 4 and 5, except that I have the input going to pin 4, which is B1, and the output going to A1. It shouldn't go that direction. It's going backwards. I just realized the other thing were kind of wrong in that regard. If I swap them, if I put the input in A1 on pin 5, and then B1, which should be the pass-through, we don't get a signal. Then if I turn the chip off, I'm going to swap it out with the one from the other board, turn it back on. Now we get it. Oh, at least it was momentarily? Well, that's weird. There we go. I may have bumped the jumper wire or something. There are 2 layouts for this chip on the Discord channel. One of them inverts and one of them does not. No, what do you mean, Spongy? Don't tell me there's two different revisions of this chip that do different things. Okay, hold on. Off. Swap. On. And it doesn't work. One is drawn negative logic and one is in positive. Is the direction pin floating? No. There is no direction pin. So we have the AN pin and we have the BN pin. The AN pin is tied to ground. The BN pin is also tied to ground. If we go and we look at the pin descriptions, AN, when asserted low, enables A pins as inputs. We are putting the input into A. BN, when asserted high, enables B as inputs. We have it tied positive. No, we have it tied to negative here. There is no direction pin. That's not how it works. Or there's not one direction pin, I should say. But it seems like this chip may be constantly working in the wrong direction. So this might be worse off than we thought. Let's swap it out one more time. All right, turn it back on. It's working. Now I'm going to put the output on pin 3 and the input on pin 2, and there it is working as well. So this chip appears to be working just fine. It is also not getting anywhere near as hot as the other one. So I think the other chip was toast and working very, very wrong. Truth table. Yeah, it was somewhere around here. There you go, truth table. But we shouldn't have been getting backwards data no matter what. Maybe, but the chip is behaving incorrectly no matter what. So it doesn't really matter. All right, we're going slight overtime because I'm not going to be able to sleep if I don't get this thing in there, in the CPU board. So, all right, I'm satisfied with the tests there. Again, SigGen was very useful. We characterized a completely different failure mode than I expected there. Let me swap over to the non-Gigantor tip here. Turn that on. Do you have one of those logic probes with the LEDs? I do not. Still recording, not currently. I have been recording off and on. And I should start now. Well, I think that's enough due diligence. Let's get a socket put in here, and then, yeah, we'll see. Actually, one thing I wanted to look at, I wanted to make sure no solder dripped down from the other chip as I was working on it. So I held it up there, so it would have fallen this way, because it rained a lot down onto the table when I took the part out. Just make sure there's no shorts. It all looks good. All right, I think we're going to be safe there. Hopefully nothing got under a part or something. Gosh, that would suck. But all right. Let's put some chip sockets in. And we're ready to find out if this thing works. Oh, that wasn't a pin. What? I guess that was just a via. All right. That's not going to fly. This needs to be shaved down even more. Ugh, come on. Screw it. I'm installing it backwards. It's a Dell something or another. I don't know exactly what. I'm going to put the bad part back in here. Just make sure that these stay aligned, because why not? Because it doesn't want to. That's why not. Okay, this is going to be fun. Actually, let me flux all of this. Especially for the ones that don't have angular rings. Those are going to be a nightmare. Okay. There, here is our freshly installed socket. And with that, we can put in the new 634 chip here. It does not want to play nice. Let me make sure all the pins are fully straight, and I might flux and flow the solder that's on them. I'm putting the other chip in first since this is a brand new pair of sockets. I want the first stress to be on a chip I don't care that much about. That worked. Okay. There we go. That's in. And height-wise, it is barely taller. Maybe just as tall as those resistor packs. This one, it might actually be shorter. Ooh, it's real close. This might be an acceptable long-term solution. It's... but we're ready to try and turn it on. Logic probe with the LED. Oh my gosh, that's expensive. Okay, that's correct orientation. I think we're ready. Oh my gosh. But HP, yeah. Oh, Ben. You're concerned about the async card. I can prove you wrong immediately. Never mind, I can't. I was about to say something, and then the words were going to be all wrong, so don't worry. Never mind. I've done too many things on this. My brain's all over the place. Ah. No, no, no. sync card not being installed means I couldn't even change a memory if I tried. So never mind. All right, we are doing this in 2 steps. I'm going to turn the computer on first with only the CPU card installed, because we have already seen what happens when there is a short. The bat light never turns off. So if somehow I screwed something up, some solder blob fell somewhere it shouldn't have, or something like that, I would like to only risk this card. This is the most important card, but if I'm going to risk one, I'd you know, minimize risks. That's basically it. All right, here we go. You know, it'd be cool if I plug this into the wall. All right, here we go. I did not see the AC power light come on. You know, it helps if I plugged in the front panel. Okay. Bat power light turned off. Okay. Everything there looks good.
Get some rest, dude. CHER 100. End of line.
It's time for async card. 9876 goes here. All right, I need to go plug in the terminal. Never mind, terminal's plugged in. Why did it not turn on? There we go. All right, moment of truth. Let me do this. All right, moment of truth. Technically, I believe when I go to run, it should start the console automatically. I should not have to press PL start. Okay. That's not great. Okay, so at the least it didn't fix that issue. All right, real quick. We're gonna probe the RAM chips. All right, logic analyzer is loading. Okay, system, logic analyzer, waveform. Okay, so this is roughly what we should see. So let's run. No chip select. Okay, I'm gonna go to run. Still not seeing chip select change. All right. Yeah, I can do that, but pretty sure it's not going to. Oh. When I hit PL start, chip select does go. Okay. That's something. All right, let's put in the serial board. Okay. Chip select toggling. That's completely new. It just dropped to the monitor. Oh my gosh. Here we go. This is moment of truth. Where are we? 7-0. That's a value. That's a value in memory. That's different. That's different. Oh my gosh, hold on. 2. Okay, I don't know why 2 would be that. Let's set 2 to 1. 2. Yes! Yes! It worked! We just set memory! That's it! That's it! That's the whole thing right there! Oh my gosh! Oh! That's it! We can do 1, 2, 3, 4, 5, 6. We're gonna go back to 2. We're gonna view these 2, 3, 4, 5, 6. That's working! Yes! Oh my gosh. That is such a huge step. Oh man. Whew. Okay. I am so excited. Oh man, all right. Whew. That's so good.
LUCKYBOP 77 SIs. I've never seen anyone happier to turn a 2 into a 1. CHEER 100. End of line. Coracoon says CHEER 101 small step for soldering, 1 giant leap for Shelby's sanity. End of line.
That is officially the Data General microNOVA working. It should be possible to put code into the 2 to 37 register location now and be able to actually set data and execute it.
I have rarely been pleased to be proved wrong. CHEER 150. End of line.
Oh, man. All right, this is just for the video, okay? This is just for the video. Well, on that, I have a lot more work to do still. We have the floppy drive potentially working, but we're not ready to try and boot from it yet because that floppy disk has not been imaged, and there is zero chance that I am putting the possible only Data General microNOVA boot floppy known to exist into a drive that we don't know how works just to see. So my next now is figuring out how to image a hard-sectored 8-inch floppy disk so that we know we have a good backup that we can try to boot a real operating system on the microNOVA. The fact that I'm even saying words even reminiscent to that is making me so happy. This is incredible. Well, thank you to Usagi again, who has been helping me troubleshoot through this. I really appreciate that. But that's the microNOVA working. We still have to put in all of the other RAM, the other async card. There is more to do, but that is the minimum necessary stuff to make the computer work. So I am super happy. If you enjoyed this video, you may want to subscribe to be notified when I release another one. If you want to help support the channel, you can find me on Patreon. But for now, that's it, and I will see you next time. All right, there we go. So that's the end of the video. I could cry. I'm so happy. Oh my gosh.
Gave a tier 1 gift sub to 5 viewers. End of line.
Hold on, I have not been paying attention to donation stuff. I really appreciate it all. Let me catch up here. Oh my gosh. It actually works. We successfully diagnosed it. Oh man. So, Sleepy Developer, thank you for the 250. DDOPS, thank you for the 30. Lucky Bob, thank you for the 100. Chloe, thank you for the 100. Spongy, thank you for the 200. Ben, thank you for the 150. JJ, thank you for the 5 gifted subs. Oh my gosh, I'm so happy. Oh man. Whew. Comedy option is to ignore. Doridian, thank you for the Prime sub there. I appreciate that. And for the first time. Dude, it's working. It's working.
NEOPRAGON 90SICHER 100. We can write memory.
We can absolutely write memory. Oh my gosh. Yeah, so Helencroft, I don't know how to load that. So here's the thing. Those are 9-track files that are meant for H, I believe. And I did look at some of them because I have the entire Novas Are Forever site archived in my server now and is looking through all the files. They appear to just be binary data. So if someone were to say, write a serial monitor wrapper program for, you know, a Data General microNOVA in Python that's already in progress on GitHub, it might be possible to just dump the binary to memory and then run it. I don't know. We will be exploring that option. But I don't know how to load those or convert them to floppy disks. Here's the thing. We need to get a rip of a floppy, no matter, just a floppy, to know what the structure even is to make a disk. Because we have no idea what the disk structure is. I bet the manual talks about it somewhat, but it's going to be way more important to just have one done. Because again, the other thing is, can we even write? We can't write a hard sector disk if we can't read it. So, yeah. First we need to write mem test for the Nova. I think that's going to be pretty easy. We just, you know, punch in numbers, write value, and then read value. We'll probably do that manually. Or we'll use my external wrapper program to do that. But yeah, oh man, dude. And yeah, why did it start working when I plugged in the logic analyzer? I don't know. It's possible we still have the same problem where it does not boot consistently. What's causing that? I don't know. Could be the switch in the front sucks. I don't know. But yeah, oh boy. 0 ohms, so I have some Track 842 8-inch drives right there that I've already refurbed and used with a grease weasel. The hard sectored issue is the thing. I need to figure that out. So we can maybe start to try and figure that out tomorrow. I don't know. We're going to look at our options. We have 2 paths that we can go down here. Well, actually, let me... I want to shut this off because, like, we're done with it, but I'm also sitting here just staring at it, and I'm so happy. Let me show you the paths that we can pursue from here. We're the microNOVA, your logic analyzer, spend a simulator. It's futile, yeah. All right, so wakey, here we go. What do you mean battery low? Oh, it isn't plugged in because I made the exact same mistake. I plugged in the USB end. I did not plug in the like actual power end. Boom. There we go. Okay, so back to this. Okay. Oh, all right, so this is my my wiki page for this thing, and down here is my project roadmap. We just finished write and read access to the memory. We don't know about startup inconsistency, but as long as we get it to start sometimes, who really cares? So we're past that, which means we have serial interfacing, which is related to the code I was hinting about here that I've already started working on for being able to read and write memory, on the Nova. But let's just not worry about that for the moment. We can work on this. Now, initially I was going to start on this before we started on the floppy drive, but we went ahead and refurbed the floppy drive anyway, just as a test, because we didn't know if it would have a ROM or something that the system would try and use. So refurb dual 8-inch floppy drive is done, tentatively. We don't really know, which means we're also at the point where we can image 8-inch boot disk. So we have this part of the project and this part of the project to work on right now. Once both of those are complete, because I want to be able to do both of those, we'll be able to boot the machine. So, and then we got the horrifying parts. But we can work on either one of these right now. So, assume the older the drive is, more likely to work with hard sector floppies. The problem isn't the drive, it's the controller. And the controller in this case is the grease weasel. The grease weasel doesn't have true native support for hard sector disks. It has some kind of hacky workaround support where you over rip the disk and then it just tries to figure it out after the fact. So, I don't know. But oh my gosh. Supposedly the CryoFlux might support it, and that's one of the things where I just need to sit down and try it. I've been too focused on this to be able to try anything else. So, nothing else has gotten any attention at all. But yeah. That's where we're at. So serial interfacing and image 8-inch boot disk. And once we've done this, we can bring it in with that and then try and boot. Here's the thing. We're never, ever, under any circumstances, putting the original boot disk in the original drive. That's not happening. The original boot disk should do the Track drives once, read, and then put on a shelf for the rest of time. Oh yeah, here's the thing. I think CryoFlux can read a hard sector disk, but it cannot write it. I think that's the problem. There's no point in reading the disk if we can't write it. Because if I can't duplicate it, what's the point? Oh yeah, I hypothetically someday in the future maybe can make a duplicate of it. That's not acceptable. So we're only going to attempt to boot a duplicate of the disk. I have a lifetime supply of hard sector 8-inch disks. I'm not worried about that part. We can make another disk. But I have to be able to write the disk back, and I don't believe the CryoFlux can do that. I think that's the limiting factor. So that's where we're at. We need to figure out something. And ripping the 8-inch disks, no matter what, will be possible because of the 3 options I have listed here, and Floppy Poser would make that possible. So we might have to go back to that project for this, but we'll see. We'll see. We have support based on images from CryoFlux, but I haven't tested it ourselves. Yeah, that's all the things. We need to sit down and try this stuff. That's where we're at. There we go. It just worked. It works. it works. Next, restore the donor RAM card. That is a goal too. I do want to do that. Dude, I don't want to shut it off because I'm still so giddy that it works, but like I do need to leave at some point. So there we go. I'm gonna take a picture of this though. Oh my gosh, it just worked. It worked. You know what? I'm really curious here before we end this. What happens if I turn it on again right now? Will it properly go into the console? It went straight into the console. That's what it's supposed to do. Maybe I didn't have the card plugged in all the way or something. That's correct behavior. One, Control L, 2, 1, 2, 3, 4, 5, 6, 2. It works, oh my gosh. Oh, it's so good. It's so good. Oh man, I'm excited. All right, I'll stop holding you guys here. Let's go ahead and wrap this up. Oh man, I'm so happy right now, dude. Oh. What am I looking for here? I'm looking for that. Hide that, and then I need this. Oh man. Vorpal Sword, you can see all that on the wiki as far as it's documented. I do have all that information there. Okay, well, thank you all so much for being here. This was a momentous day. I am extremely excited with the results of today. That was fantastic. It works. That's crazy. If you all watching live, first off, thank you for being here and hanging out with me. This is so much fun. I'm really glad I get to do this, and that I'm glad you guys enjoy it, and it's just this fun thing. But thank you for being here and watching this. If you enjoyed this one, you may want to follow to be notified when I go live again next, which will be 19 and a half hours from now. If you want to support the channel, you can find me on Patreon or get a shirt like this one. But that's going to be it for now, and I will see you all next time.